I want to take the derivative of a of x equals 1 over x. So I'm going to calculate a prime of x. So can you walk me through the quotient rule pattern real quick? I have f over g and you take the derivative. Then that derivative is going to be, so I'm going to write out a prime of x is f prime g minus f g prime all over g squared. And as long as I can identify f, g, f prime, and g prime, then I'm going to be good to go. So my f is whatever my top is here, is 1. My g is x, so what's f prime? I can replace f prime with 0. F prime is 0, so I have 0 times x minus 1 times 1 divided by g squared, so x quantity squared. Then I'm going to take a prime of x. Now I can clean this up a little bit, right? Because 0 times x is equal to 0, so why write it? Minus 1 times 1 is equal to negative 1, and x squared is equal to x squared. So if I do quotient rule and I take that, I get that answer. So that's good, right? Now the question is, could I have done this a different way? Because when you do a derivative, it's good to think about, could I have done this a different way? And so the other way you could have done this is you could have rewritten 1 over x algebraically. A over x is equal to 1 over x. Well, I can rewrite that using properties of exponents as a of x is equal to 1 times x raised to the negative 1 power. Now, if I look at it this way, can I take the derivative without quotient rule? This constant is being multiplied by something, so it's just going to hang out. So you did the derivative perfectly there using power rule. And then from there, we are going to take that power rule and we are going to rewrite this as a prime of x is equal to negative 1 times x to the negative 2. Which then becomes, now I want to rewrite this so it looks, I don't like writing things with negative exponents if I can avoid it. So I've taken the derivative perfectly, but now what would we do to rewrite this in a form that we, negative 1 over x squared. Now notice, that's the same thing that we got in both places. So we wound up with exactly the same answer using these two different approaches. Which approach did you think personally was easier once you did both of them? So it's totally up to you which one you prefer. 10 over x squared is the same situation. B of x is equal to 10 over x squared. Option 1 is to do quotient rule. The other option is to rewrite algebraically and do power rule. And both of them will get you to the equivalent answers, so it's up to you which one you like. Which one do you want to do first? F is 10, so f prime is 0 because 10 is a constant. G is x squared, so g prime is 2x. So I plug that into my quotient rule pattern, which would say b prime of x is equal to, which is then plugging in everything, f prime is 0 times x squared minus 10 times 2x all over x squared quantity squared. I have to square the denominator. So this is really, really silly. But I imagine a person walking through a place called denominator square, and they have to go down into it. So they go down and they walk through denominator square. So I remember the denominator is squared. And so x squared squared, I would want to clean up a little bit. 0 times anything is 0 minus 20x all over x to the 4th, and then b prime of x is equal to 0 minus 20x is just negative 20x over x to the 4th. And then finally, b prime of x is equal to negative 20 over x cubed. So I have an x to the 1 on top and I have an x to the 4th on bottom. So the way that I think about this is negative 20 times x over x times x times x times x. I'm canceling and I'm just left with 3 x's on the bottom and no x. Now you notice we did a quotient rule here, which meant we could just jump right into it. But we still had to do algebra because we didn't want to leave it like this. So the algebra came from simplifying after we applied the rule. Now let's go ahead and just do it. What would it look like if we rewrote it algebraically and did power rule? So if I rewrote b of x equals 10 over x squared, I can bring this x squared up and I can rewrite it as b of x is equal to 10 times x to the negative 2. Now, lots of times people think, oh, I took the derivative. This is not b prime. This is just b of x, a different way of writing it. So then my thing is, okay, I have my b of x. Now can I do b prime of x here? Well, what happens to this 10 when I take the derivative of 10 times x to the negative 2? It just stays there. So it stays as 10. Then the derivative of x to the negative 2 is times negative 2 times x to the negative 3, which means that b prime of x is equal to negative 20 x to the negative 3. And then I get this b prime of x. So I'd like to bring this back down. So this x to the negative 3 means whenever I see a negative exponent, that means it might be happy living in the base. So negative 20 over x cubed. And notice again, we got the same thing either way that we did it. Question is, do you want to do the algebra as the first step to make taking the derivative easier? Or do you want to do the algebra first so that when you take the derivative, it's already pretty much simplified? Or do you want to take the derivative first and then you have to fight through more algebra to simplify it? And either way, you're going to have to do algebra and take the derivative. And either way, you'll get an equivalent answer. It's just a matter of which one you like better.